This conference will now be recorded.
Okay, let's start. So in the last class, we discussed about read statement on what standard internal table. Okay, now, and we have seen a standard internal table with what non-unique key. Okay, now let us go for what sorted internal table. We have another type of internal table called as what sorted internal table. Okay, so let us do that. Sorted internal table. Yeah. Okay. So how do you declare the internal tables? First, we'll create the types declaration. So I'll say types begin of ty underscore emp. I'll declare some fields inside this. I'll say employee number type I. Then let me take employee name of 20 type C. Then employee designation of something 25 type C. I'll close the types declaration. End of ty underscore emp. Now based on this types declaration, we can create the internal table. So I'll say data, let me say t underscore emp1 type. So far we used to say what type table of, which is understood as what standard internal table. Now let me declare sorted internal table. So I'll say type sorted table of, what is the type name, ty underscore emp. So earlier we have seen we can declare the standard internal table either with a key or without key. And if you are defining it with a key, it supports only what non-unique key. It supports only non-unique key. So here also I am trying to declare the sorted internal table without header, and I am not giving any key. Let's see whether we will get any errors. Then since it is without header, I require what work area. So w underscore emp type ty underscore what emp. Done. Let me check for the syntax errors. Yeah, when I do syntax check, I am getting an error. The key is not specified in full. The key is not specified in full. Types specified generically are completed only in what standard table. So what it is saying is only in standard internal tables I can create it with key or what without key. But in case of sorted internal table, key is what mandatory itself. The key is not specified in what full. So key declaration, key specification is mandatory in case of sorted internal table. So if I give like this, it is giving me the syntax error. So let me comment it for your reference. I'll say syntax error. Okay. So let me say whether it supports what non-unique key. With non-unique key, what is the field you want to declare the non-unique employee number. Okay. So I'm declaring the sorted internal table with non-unique key. Let me save it. Check for the syntax. No error. So what is the meaning? It supports what? Supports non-unique key declaration. Let me check whether it supports unique key declaration or not. Okay, so I'll just give a comment. Supports. Then I'll say data t underscore emp1 type sorted table of so and so with the unique key employee number. So when I do syntax check, yes, it supports. So what is the meaning? Sorted internal table supports both non-unique key as well as what unique key, whereas standard internal table supports only what non-unique key. Okay, this is the first difference. Okay, and another difference is for standard internal tables the key declaration is what optional, but whereas for sort internal table compulsorily we need to declare the key, and it supports both unique as well as what non-unique key. One second. Okay, so I declare it. Done. So what is the meaning of sorted internal table? While adding the entries itself, it is going to sort the data in what sorted order of the key field. Whereas in case of standard internal tables, in whatever way we have added, the same way it will take. If you want to sort it separately, we have to use a sort statement. But whereas in case of sorted internal table, while adding the entries itself, it is going to arrange the data in the sorted order of the key field. Done. Now let us try to add the entries inside this. Clear. Okay, clear. Before adding the entries, better we clear the work area. So clear w underscore emp. Then I will say w underscore emp hyphen employee number. Then w underscore emp hyphen employee name. I'll give some employee name. Then w underscore emp hyphen employee designation. Then okay, that's it. So in the earlier cases, we have seen that for standard internal tables, we can use both append and what insert statement. Append will always add the data to the end of the internal table, whereas insert can be used either to insert at the end or at a specified index position. Now let us check whether sorted internal table supports both append and insert or not. So I'll say append w underscore emp2 t underscore what emp1. Done. Let me add one more entry. Employee number, let me say something 7. I'll give some data. Some designation. Right, so I've added some 3 records. Okay, so what type of internal table this is? Sorted internal table. So what is the meaning? While adding the data itself, it is going to sort the data in what? It is going to arrange the data in what? Sorted order of the key field. What is the key field here? Employee number is the key field. So now what is the order I am inserting? 5, then I am inserting 7, then I am inserting what? 10. So I am only taking care of what? Sorting sequence. I am only adding the data in what? Ascending order. And already we know append statement will always add the data to the end of the internal table. So let's see whether it's supported or not. Let me loop and display. I'll say loop at t underscore emp1 into work area w underscore emp. Then I'll say write w underscore emp hyphen employee number, employee name, and employee designation. End the loop. So the focus here is I am trying to use append statement, and append statement will always point to what? End of the internal table. It will try to add the data to the end of the internal table, and I am adding the data in what? Sorted order. Sorted order of what? Employee number 5, 7, and what? 10. So let's see whether it works or not. So when I execute, yes, we are able to add the data and working fine. So what is the meaning? I am able to use what? Append statement. Now what I'll do is just try to understand. Here I'll try to add one more record. Let me give employee number as something 6, and employee name I'll give it as something Ashok. Okay, right? So I'm trying to add one more record with employee number 6, and I'm using what? Append statement. What is the behavior of append statement? Append will always try to add the data to the end of the internal table. So it will try to add this employee number 6 to the end of the internal table. But my internal table is what kind of internal table? Sorted. Okay, what is the key field I give? Employee number. So it has to arrange the data in what? Sorted order of what? Employee number. So according to the sorting sequence, this employee number 6 should come between what? 5 and what? 7 now. Employee number 6 should come between 5 and 7. But I am using the append statement. Append will always try to add where? To the end of the internal table. So we are instructing to add at the end of the internal table. But since it is a sorted internal table, the sorting sequence will be destroyed if you are trying to add at the end. Let's see what happens. No syntax error. Okay, I don't have any syntax error. Okay, let me execute this. Yes, I got the runtime error. What is the runtime error I got? Error while inserting or changing rows in a sorted table. Error while inserting or changing rows in a sorted table. Error analysis. An attempt was made to insert or change a row in the internal table, sorted internal table, at the position what? 3. At the position 3. This corrupted the sort sequence. Defined for the table by its key. So am I clear? So see where I am getting the runtime error. If you scroll down, yeah, you can see the arrow pointer here. I am getting this statement execution, 40th line execution, is leading me to the runtime error because we are using append, which will try to add the data to the end of the internal table. But since it is sorted internal table, it has to sort based on the employee number while adding the entries itself. So the sorting sequence will be destroyed. So I got the runtime error. Okay, so what is the understanding? Can we use append statement on sorted internal table? Yes, we can use, but we should ensure the sorting sequence based on the key field. If you are not ensuring, there is the possibility of leading to what? Runtime error. So blindly we cannot say that append is not supported. Append is very much supported if you are ensuring the sorting sequence of the key field. Otherwise, it may lead to what? Runtime error. So what I will do here, just I'll comment it. So this will lead to what? Runtime error as what? Sorting sequence of key field. What is the key field? I specified that employee number is what? Destroyed. Okay. So what I'll do, instead of using append statement, I'll try to use insert statement. Insert w underscore emp into table. What is the internal table? T underscore emp 1. Okay, so let me check it now. Okay, I'm looping and displaying. Let's see whether insert will avoid the runtime error or not. So what is the employee number I'm trying to insert? 6. So when I execute, good. So you can see here 6 is automatically inserted in what? Second position. Automatically inserted in the second position. That is the reason it is recommended to use insert statement rather than append statement. Because if you use append statement, we have to take care of the sorting sequence. Whereas if you use insert statement, we need not worry about the sorting sequence. Insert will automatically insert the record at the appropriate position. That is the reason it is recommended to use insert on sorted internal table rather than what? Append statement. This is one point. Another point, you see, what kind of field I gave, what kind of key field I gave? Unique key field. Unique means what? Which doesn't accept what? Duplicate values. Now what I'll do, already we have the record what? 10 Praveen and employee. So here I'll say, I'll try to add again 10. Let me give some other name. Let me give it as something Srinivas, and I'll give this as something what? CEO. I'll give it as what? CEO. Right? I'm appending the data. Okay. So append will always try to add the data where at the end. Na? So what is the largest employee number here? 10 only. Highest employee number is what? 10. So append will always add where at the end only. So this is fine. Okay, but what kind of key field I give? Unique key field. Unique means what? Which doesn't accept duplicate entries. Already 10 is there in my internal table. Again I'm trying to insert what 10. Let's see what happens here when I execute this. No syntax error. When I execute, yeah, I got a different runtime error. What is that? Error during insertion into a table with a unique key. Error during insertion of table with a unique key. See here, the table was defined with a unique primary key. No entries with duplicates can be inserted into this kind of what table. See the error analysis. If you scroll down, which statement is giving the runtime leading to runtime error? The 53rd statement. Again here also 1 second please. One second, just hold on. Yeah. So here, okay. So what is the change I have to do here? This append statement is leading to what? Runtime error. So let me just comment this. So what is that? I'll give a comment here. Runtime error as duplicate key field. What is this? Employee number found. Okay. So what I'll do now? I'll use again what? Insert w underscore emp into table t underscore what emp1. Insert w underscore emp into table t underscore emp1. Let me just execute this. Right. So what happened here? See, even though I'm trying to insert the duplicate entry, since I use the insert statement, it will ignore the duplicate entry. So that is the advantage of what insert statement means. When you use insert statement on the sorted internal table which contains unique key field, you need not worry about the duplicate entries. If you try to insert also, it will ignore the duplicate entry. This is another reason why it is recommended to use insert statement over append statement on sorted internal table, because if you use append statement sorting internal table, we have to take care of the sorting sequence of the key field, and we have to take care of the duplicate entries of that particular key field. That is the reason we always go for what? Insert on sorted internal table. But doesn't mean that I cannot use append. We can use. Yeah. Any questions so far? Please ask. So, to summarize the difference between standard internal table and the sorted internal table, the first difference is, for standard internal table, key specification field is what? Optional. But whereas for sorted internal table, key specification field is mandatory. Compulsorily you have to specify the key. Okay, and another thing is, in case of standard internal table, it supports only non-unique key, but whereas in case of sorted internal table, it supports both unique as well as what? Non-unique key field. And another point is, in case of standard internal tables, both append and insert can be used. Okay, so in case of standard, we understood that append will always add at the end, and insert can be used either to insert at the end or at the specific index position. Whereas in case of sorted also, I can use both append and insert. But when you're using append, we should take care of the sorting sequence, which is take care of what? Duplicate entries. Otherwise, it leads to what? Runtime error. So because of these two reasons, it is always recommended to use what? Insert on sorted internal table, so that we need not worry about the sorting sequence and we need not worry about the duplicate things. Yes, we can. Okay, suppose here Let me save it, check for the syntax error. Like this, Vamshi, we can give the combination of the key field. So it will check the combination every time. Means employee number can be same, employee name should be different, or employee number should be unique, employee name can be same. It checks a combination. So we can have multiple key fields also. Vamshi, this is what you are asking? Yeah, we can have multiple key fields. It checks a combination every time. Yeah, any other questions, others? Right. Now let us see whether this, okay, so when do we go for sort internal table? While adding the data itself, if you want to maintain the data in the sorting sequence, we'll go for a sorted internal table. Now let me check whether we can explicitly use a sort statement on what? Sorted internal table. So this is my current data. How many records we have? Some 4 records. Okay. Now I want to sort this data based on what? Employee name. So how do we sort the data? We have to use what? Sort statement. So sort, what is the internal table? T underscore emp1 by what? E-name. So I'm explicitly trying to use a sort statement on sorted internal table. So when I do syntax check, yeah, I am getting an error. T underscore emp1 is a table of type sorted. The sort command cannot be used with this type of table. So this is another difference between standard and what? Sorted. In case of standard, explicitly we can use the sort command, but whereas in case of sort statement, I cannot use the sort statement. Sorting is always done based on the key field mentioned as part of declaring the sorted internal table. I cannot sort it on other fields. So again, this will give me what? Syntax error. Hope it's clear. Yes, Samshi. To sort the internal table automatically and to avoid the duplicate entries, we can go for what? Key specification field. Yes, that is the purpose. So the developer has to decide. Okay, when you are creating the internal tables, no one will tell us whether to go for standard, sorted, or hash internal table. Okay, so if you want to maintain the uniqueness, if you want to maintain the sorting sequence at the time of adding the entries itself, we'll go for what? Sorted internal table, and you want to restrict the sorting on what? Other fields. At that time, we'll go for what? A sorted internal table. Done. And yesterday we have seen we can use a read statement, right, on the standard internal table. How can we use the read statement? I can use based on the index, or I can use based on the key field. So here also, let me quickly check whether it supports this read statement or not. Okay, suppose I want to read the third record. Third record means what is the index 3 na? So let me check it. So I'll say clear. Okay, let me say uline first. Read always reads the data into work area. That's the reason I'm clearing the work area before I'm using it. Read table T underscore emp1 into W underscore emp. How do you use it now? Index. Index what? 3. Index 3. How do you check the execution status of the read statement? By comparing with what? Size sub rc. Size sub rc is equal to 0. Okay, I'll just print the data. I'll just give a message also. Third record found. I'll print the data which is populated into the work area. W underscore emp. W underscore emp hyphen employee number. W underscore emp hyphen employee name. W underscore emp hyphen employee designation, else I'll give a message third record not found. So what I'm trying to check here is whether I can do the searching based on the index, whether indexed search is possible on sorted internal table or not. Okay, so when I execute, what is the error? Yeah, W underscore. Now I gave it as hyphen. Save it, check for the syntax, no errors, done. When I execute, yes, I got the third record, 7 Kiran manager. So what is the meaning? Indexed search is supported in case of what? Sorted internal table. So this is possible. Indexed search. Done. Let me check whether it supports linear search or not. Suppose here I want to search for a record whose employee number is 6. Okay, I want to search for a record whose employee number is what? 6. So I'll say, so I don't know the position now. I know some information about the record. What is that information? Employee number is what? 6. So read table T underscore EMP1 into work area. How do you do it? Based on the condition with the key. With the key, what is this? Employee number is equal to what? 6. So this we call it as what? Linear search. Linear search means sequential search. It starts searching from what? First record to what? Last record till the condition is what? Satisfied. So I'll just give the meaningful message here. Employee number 6 found. I'm printing the data. Here also employee number 6 not found. Okay, so when I execute, done. So I got the data. 6 Ashok and what? Employee. So what is the meaning? It supports what? Linear search. I mean to say sequential search. Linear search is what? It starts searching from the first record one by one till the condition is what? Satisfied. So this is supported. Let me check whether it supports binary search or not. Binary search or not. Means now I want to search for the record whose employee number is 10. Yesterday we understood that in order to use binary search, the data should be in what? Sorted order based on the search field. Here I want to search based on the employee number. Anyhow, the data is in sorted order of employee number only. Na? For this internal table, what is the key field? Employee number. So it is going to sort on what? Employee number by default. So explicitly, anyhow, I cannot use the sort statement. So assuming that since the data is already in sorted order, I'll try to use the binary search directly. So I'll say read table T underscore EMP1 into work area with key employee number equal to 10. I'll try to use the addition what? Binary search. Okay, binary search. So let me just change the comment. Binary search. So I'll say employee number 10 found. If size about is equal to 0, employee number 10 found. And here I'll say employee number 10 not found. So I'm trying to use binary search. What is the concept of binary search I told yesterday? It will identify the middle record in the internal table. Starting from the middle record, it will decide whether to search in the upward direction or whether to search in the downward direction. So we are minimizing the searching process. We are improving the performance of our read statement by using what? Binary search. So when I execute now, yes, I got the data 10 Praveen employee. So which means what? Binary search is also supported. So to summarize, sorted internal table supports all types of search. Indexed search, linear search, and what? Binary search. Indexed search means if you are using the read statement based on the index. Linear search means, that is sequential search means if you are using the read statement based on what? Key field. And binary search means what? If you're using the read statement with the addition what? Binary search. So it supports what? All three kinds of what? Searches. Done. That's all. These are the points related to sorted internal table. I'll repeat this once again. If you have any questions, you can ask me. 1 second. Just hold on, please. Just hold on. right? Okay, so I'll summarize this. What is sorted internal table? While adding the data itself, SAP will arrange the data in what sorting sequence of the key field. And when you're declaring the sorted internal table, declaration of key field is mandatory. It supports both non-unique and what unique key. Non-unique means it is understood that it can hold duplicate values. Unique means what? It will not hold the duplicate values. And we can use both append and insert statement on sorted internal table. But when you are using the append statement, we have to take care of the sorting sequence of the key field. Okay, and also if it is a unique key field, we should not insert any duplicate values. Otherwise, these two statements may lead to what runtime error. Because of this reason, it is recommended to use what insert statement over append in case of what sorted internal table. And explicitly, we cannot use the sort command on the sorted internal table. And sorted internal table supports all three types of searches: indexed search, linear search, and what binary search. Any questions, please ask me. Okay, so now let us go to what ASH internal table. So I'll just copy this 23rd example to 24. 23rd I am copying it to 24. Yeah. So before discussing this, so what we are trying to declare ASH internal table. Okay, so ASH internal table. Okay, ASH internal table. Okay, supports. Sorry, not supports. ASH internal table internally uses ASH algorithm. Internally uses what? ASH algorithm. Okay, so according to this algorithm, okay, it supports searching based on what key only, not on what index. Okay, according to ASH algorithm, indexing is not possible. Indexing is not possible. Only searching is possible based on what key field, based on the key field, based on the key only. Okay, so I can say that this ASH internal table doesn't support what explicit or implicit index operations. It doesn't support what explicit or implicit index operations. So when I say implicit index operations, what is the meaning of that? Okay, it doesn't support append statement. Means what is the meaning of append? Append means indirectly we are telling to add the record to the end of the internal table. Indirectly we are telling the position. Append will always refers to what end of the internal table. So indirectly we are telling the position, nothing but what implicit index. Append always points to what at the end. So append is not supported. Done. This is one thing. Another point is what in the read statement, if we use read with binary search, what is the meaning? We are indirectly telling to search for the record from the middle. So indirectly we are telling the position, that is middle. Again, this is also not supported. These two comes under what? Implicit index operations. Now when I say explicit index operations, okay, I cannot use insert with index is not possible. We should not specify any index. I can use insert statement, but plain insert without using any index. If I use insert with index, it gives what error. Then again, what else? I cannot use read with index. This also comes under what? Explicit index operation. Right? So to summarize, ASH internal table doesn't support explicit or implicit index operation. So implicit index example is what? Append and read with binary search. Explicit is what? Insert with index and read with what? Index. So let's see these things. So already I copied, I think, right? Let me check. Yeah, already copied. So 24, I'll make the necessary changes. So see this. Yeah, so here let me comment everything. I'm commenting everything. Yeah, I commented. Now here what I'll do is I'll say, let me comment this too also. Yeah. I'll say data t underscore emp1 type what? Hashed table of type hashed table of so and so, done. So what I am trying to do here, I am trying to declare a hashed internal table without any key, so this is very much valid if it is a standard internal table. I can create that standard with key or what, without key. I am trying to do the same thing for what, hashed internal table. Let's see whether we'll get any errors. Good. I got an error, similar error. What is that? The key is not specified in full. Types is specified generically or completed only in what, standard tables. Only for standard internal tables I can declare without key. So this is giving me what, syntax error. Done. Then I'll say data t underscore emp1, again let me say hash table of. What I'm trying to do here, I'm trying to define a non-unique key. Okay, a non-unique key. This non-unique key is very much supported for standard as well as what, sorted. I am trying to do the same thing for what, hash internal table. So when I do syntax check, again I got an error. Hashed keys must be unique. Hashed keys must be unique. The addition unique must be specified in case of what, hash table. So to understand what is the meaning here, for hashed internal tables, key specification is what, mandatory, and it supports only what, unique key specification. So this is giving me what, syntax error. Then again I'll say type, what is this here, type what, hash table of, type hash table of ty underscore emp with unique key. Done. So let me check it now. Yes. Okay, so it supports only what, unique key. Done. Now let me check whether it supports append or not. So what I'll do here, I'll say I'm adding some data and I'll try to use append. Append means indirectly we are telling the position. Indirectly we are telling the position where to add. But hash internal table doesn't support explicit or implicit index operation. So it should give me what, syntax error. Good. What is the error I got? See, explicit or implicit index operations cannot be used on tables with types what, hash table or any table. T underscore emp1 as a type hash table. It is possible that the addition table was not specified. This one. So we're done. So what is the meaning is, it doesn't support what, explicit or implicit index operation. So how do we add the data now? 1 second please. Yeah. So let me just comment this. What I have to use now in order to add the data, I must use what, insert statement. So I'll say insert what, w underscore emp into table what, t underscore emp1. Save it, check it, no errors. Done. Let me do the same thing for the other two records also. Append. So this will give me what, syntax error. For your reference, I am commenting this so that when you are practicing in your systems, you uncomment and practice so that you will get the errors and you will understand the errors. Done. So here also same thing. Right, save it, check it, no errors. Let me try to loop and display that. So I got the data. Okay, I got the data. So what is the meaning? I am able to use insert statement. Let me try to use insert with index. Suppose here I'll say insert w underscore emp into t underscore emp1. I'll say index what 2. I'm trying to insert in the second position. Let me check the errors. Yeah, I got an error. Explicit or implicit index operations are not possible. So explicitly I am specifying the position. Again, this is not supported. So this will give me what? Syntax error. This also will give me what? Syntax error. So I can use only plain insert statement without any index. Done. So I got the data. Right. And what kind of key it supports? Only unique key. So even if you try to insert duplicate entries, it will ignore. Suppose here only, I'll try to insert duplicate record. Okay, let me give 10. I'll give this as something Ashok and so on. So 10 is already there. So it will not insert two employees with employee number 10. It will simply ignore that because it is what? Unique key. Whatever the first value is there, it will consider that value only. If you're trying to insert the duplicate entry, it will ignore that. Okay. So what happens here? Ignores duplicate record without what? Insertion. Ignores duplicate record for unique key field without insertion. Done. So it will not give any error, simply it ignores that. Done. So we understood that I can use only append statement. Sorry, I can use only what? Insert statement, plain insert statement. Okay. Now let me check whether I can use sort statement. Okay. So sort t underscore emp1 by employee name. So let me try to redisplay it whether it is sorted or not. So I'm sorting it based on employee name. I'm explicitly trying to use a sort statement. So when I execute, yes, I'm able to what? Sort. I'm able to use a sort statement. Okay, so it supports what? Sort statement. Done. Let me check whether I can use what? Read statement with index. Again, we are telling the position now. So it should give me what? Syntax error. So when I do syntax check, yes, I got the similar error. Explicit or implicit index operations are not possible. So again, this will give me what? Syntax error. So let me comment it for your reference. Syntax error. Done. Now let me check whether I can use binary search. Sorry, linear search. I'm trying to use linear search first. Linear search will be supported, okay, because I'm not giving any what position here. I'm not giving an index here. I'm searching based on what key. So when I execute this, no errors. Yes, I got employee number 6 not found because 6 is not there. Okay, let me search for 7. So that you'll get the record also. Yes, I got the data. 7 Kiran and what? Something what? Manager. I got the data. So what is the meaning? It supports what? Sequential search. Let me try to use read with binary search. So I'll say with employee number equal to binary search. Binary search is what? Again, indirectly we are telling the position to start searching it from what? Middle of the internal table. So when I execute this, yeah, I got a similar error. Explicit or implicit index operations are not supported. So I cannot use read with what? Binary search. Again, this will give me what? Syntax error. Okay. So now, when do we go for hash internal table? Okay. So just see this. See the concept here. In what cases you'll go for hash internal table is, suppose, try to understand. I'll take a standard internal table or sorted internal table. Try to understand. It can be a standard internal table or sorted internal table. Now, at this stage, these internal tables is having some what 1000 records. Okay, both these internal tables are having 1000 records. Now, I am searching for a record. Okay, I am using the read statement. I am searching for a record on this particular internal table. So, how do you search for a record? By using what? Read statement. So, when I search for a record, overall how many records are there? 1000 records. So when I'm searching for a record, assume that it has taken some 2 milliseconds. It has taken some 2 milliseconds to give me the what result, to give me the result. Okay, now on the same internal table I'll increase the count to some 50,000 records. I'll assume that now at this stage there are 50,000 records. Again I'm searching for the record. Again I'm searching for the record. So when I use the read statement on this now this time it may take some 3 milliseconds because the number of records are what increased. So assume that we are having some 1 lakh records. Again I am using the read statement. This time it may take some 5 milliseconds. So what you have to understand here, the time taken to search for a record depends on what amount of entries, depends upon what number of entries. In case of what standard internal table or what sorted internal table, means if the data increases, obviously the searching time also will be what more. But if you take hash internal table, okay, if you take hash internal table, okay, in case of hash internal table, irrespective of the number of entries, the time taken for searching a record is always what constant, is always constant. Initially you may have 1000 records, later on you may have 1 lakh records. It doesn't depend upon the number of amount of entries. So what I can say is, whenever you are dealing with huge amount of data, we will go for what hash internal table, because when you're searching for a record, it doesn't depend on what amount of entries, number of entries. Always the time taken is what constant. But whereas in case of standard and sorted, if the number of entries increases, obviously the time taken for searching a record will what change. So for storing, for dealing with what lesser amount of data, will go for what standard or what sorted. But for huge amount of data, it is recommended to go for what, it is not compulsory, it is recommended to go for what hash internal table, because the time taken for searching a record is always constant. It doesn't depend on the size of the internal table, I mean to say amount of entries in the internal table. Done. So it is a developer choice whether to go for standard or sorted or what hash internal table. So any questions, please ask me. Done. So we have done with most of the statements related to internal table. We have some more statements. We have what collect statement. Okay, those things will come in the coming sessions. What is the actual size of internal developments? It depends on the data. Depends on the data you are storing. Dynamically, the size would be allocated. It is not fixed. The internal table size will automatically extend dynamically depending on the amount of data you are storing. It is not fixed. It is not constant. The size will vary depending on the number of entries, amount of entries. It is not static. It is always dynamic. Done. So before we discuss other statements related to internal tables, what we will do from tomorrow is, so far we are filling the data in the internal table manually. Tomorrow onwards we will see how to interact with the databases by using OpenSQL and what native SQL statements, and we'll retrieve the data from the database and we'll try to evaluate the performance, how much time it has taken to retrieve the data, to process the calculation, all those things. We'll start discussing it from tomorrow onwards. Done. Any questions? I'm not following the syllabus sequence, so don't worry about the sequence. Okay, I'll be shuffling from here and there. Whatever the dependencies there, first I'll cover those things, then again I'll come back to what other things. Okay, so I'll wind up for today, then I will continue tomorrow. I will start with what database programming. Sure then. So I'm winding off for today.